Hello. This lecture today is about a new proposals for software engineering courses. This is very urgent, by the way, and this is contain adaptive learning units, ALUs, for a software engineering, unified software engineering course through knowledge patterns. This is part one. We're going to quite have a few parts here to explain the proposals in details and actually seek support and actually also make a strong message to funding agencies, and actually hopefully we'll get support from companies and individuals for doing this. So please follow me on this. This is, again, as I told you, this is it's a few pages about me to show you many different links about me. And now all the stuff is fine. The questions here which we need to answer, this is two important questions. Why we have these questions? Because software is everywhere. We have to really be able to start actually having courses to educate and to apply and to train the people doing software, because all the courses exist within the universe. They actually concentrate on programming only. And there is a reason for that. That's why the first question we're going to talk about is a critical look at existing software engineering courses or classes. Now, the other concern there we're going to talk about also is actually we look at true unified software engineering course. This is not the word unified people use without thinking. Unification means here we have to really have the knowledge within the software engineering. So most of the people who use software engineering, they have no idea what the knowledge is, which is I'm going to concentrate on this and actually get your attention on this, by the way, because again, this is now a very important point. We can kind of wasting a lot of money and developing software in the way we're doing it now, and we lose a lot, by the way. And actually, this is not appropriate. We have to stop that. So, the objectives here, we're gonna, excuse me, provide adaptive learning units, ALUs. And this is to show how to be able to see how you draw the course material for these units and how to really do it very well. Mm-hmm. We're going to look also at critical look at existing software engineering courses and motivations. As I told you, this is not about teaching. Teaching, we're going to have another critical look and provide many different ways of how to teach software engineering. Because unfortunately, people teach software engineering, they don't know how to teach it. This is not like any other course you teach. We're going to actually propose some properties, which is we have to achieve in this proposal, and we're going to establish certain goals we have to achieve as well. And we're going to talk about the proposals. This is the first introduction to. This is part one. We have conclusions and discussion. So This show you the adaptive learning units. This is introduction to them. Our proposal aim at developing adaptive learning units (ALUs) for a unified software engineering course. Emphasize knowledge knowledge patterns. By the way, we provide maps through all this ALUs because they are huge map for how to provide a course anywhere that way you want to achieve the same goals. This is very important. And we're going to provide also quizzes, exams, exercises, projects, team project assignments, materials, notes, all kind of things we're going to be providing for every unit, at least you know. We are confident that our approach will yield to the best results for your lifelong learning goals, ethics, and knowledge and applicability. All of this would be in the course? Yes. This is in each ALUs, by the way. Our expertise is unparalleled with, and we are the best choice to guide you in this journey to learn and growth. Trust us and let's get started today. This is very important. Sorry, this is kind of really going too fast. Number 3, our maps through this humongous ALUs units, it highlight the what and how, the how-to of the course. This is very important because, again, a lot of people know the what. They don't know the what, but they don't know the how anyhow. This is, again, it's not the actual how-to. This is, we're confident that our approach will be effective and beneficial. We understand that different classes and maps require various proposals, but our main focus is the lectures. In this lecture is Unified Software Engineering course. Why I'm saying that? Because you will find all the ALUs unit represent different courses in different aspects of software engineering. We are excited that and about the possibility of this proposal. Look forward to partnering with you an exciting journey of learning and growth. This is really the entire idea here. Now, adaptive unit 3, this is adaptive units. This is the major ones. So we have software stability models or concurrent software engineering models. This is a new methodology. All the existing methodology is nonsense. Now I'm going to prove that to you. This is actually no joke. We're going to have also a critical look at existing methodology in system and software engineering. We have the art of abstraction. This is another major course it should be, but this is actually have units part of software engineering for how to abstract everything in this case, by the way. Because again, our abstraction technique look for noun and noun phrases. This is a disaster. This is nonsense, by the way. Unified functional and non-functional requirements. This is, nobody knows how to do that. Guaranteed. Does not exist even in the book of software engineering or in modeling. I will show you this in every aspect, by the way. And this is very, very important. And this is represent the what. We don't know the what. Everybody write requirement. This is write an instance of requirement. And they don't know how to write. You cannot write non-functional requirement for concepts. No way. Because concepts too many. This is actually a word that has a huge number of concepts, by the way. And this concept is designed by various people, organizations, and keep going, by the way. Then we're going to look at the how unified ultimate design. Why we have the ultimate design? Because we have too many ways to provide solutions, and you become a solutions. This is not good. You have to look for the ultimate design or the ultimate solution. Otherwise, you will have a lot of trouble. Now, unified software architecture and demands. Yes, we have too many type of architectures. This is mind-boggling. We create, this is, they all map to each other, by the way, very easily. But again, this is too many of them, and we don't really, they have a lot of flaws too, by the way. We come up with an idea for how to really adopt and extend and customize. This is unified software engineer, software architecture on demand. They call it USWE on demand, by the way. This is again, we're going to provide unified immune testing environments. This is a big time thing because you could throw it in any development and it will work for you. It will really catch any errors and any virus and anything you want to, by the way. It's the way it's supposed to be. Because actually testing software, we failed completely in that. We have too many different ways of testing software. We're still a dilemma. And we do it on the wrong time too, by the way, in the wrong place. Unified domain analysis using by knowledge map. This is very important because again, we don't unify when we study the domain. We don't really define the function and non-function requirement per domain. Even per word, don't know how to do that. I have a critical look at this, and he will say, we used to have the father of domain analysis. There is no such a thing, by the way. This is again, remember, we're talking about very important field of knowledge needed for everybody, for every industry to develop anything. Cannot develop anything with software without software. That's we have to understand the requirement very well to represent the what. Nobody knows how to do that. Function and non-function requirement. The same for domain, by the way. So this is actually seven high-level AL units, by the way. This is very important for you to see. So number 4, based on what I do, a unified word, a unified domain, and actually for knowledge map, I could knowledge map for any unified word and any unified domain. They are unique. See how many words we have? Each knowledge map for every word is different, completely. There is no any similar thing there. And the similar things you will know, the applications, by the way. You saw he built an engine, he built something from this to build the engines, by the way. Then we have from this table analysis patterns. This is all the life cycle of this. They are really reusable with no any maintenance or any adaptation, by the way. Stable design pattern is stable architecture pattern, which is architecture on demand. So, algorithms, you have to understand the requirement before you write the algorithms. That's why all the algorithms we write have problems, cannot go away. So this is again overfitting, underfitting, garbage in, garbage out. This is nonsense, by the way, because we don't understand the requirement for writing these algorithms. We have to understand it first. To write an algorithms would really be, it's going to be unified algorithms. This is very important because again, it's not just an algorithms, by the way. Unified domain standards based on this knowledge map, you could create a standard for a word, per any domain. You create an executable non-function requirements. This is very, very important. We don't know how to do that. We create non-function requirement, doesn't make any sense. We don't execute it. Just kind of really on paper. Paper goes out, by the way. So now we end up based on this standard, I could create engines per word and per domain. We call it fuse. Fuse, why? Because this fuse is I took it from, it seems like what I interpreted here, Fayad, software engineering reuse, fuse, their word, I could really build system in one word, by the way. And this would be called a fuse. And for example, I could really build a debate for any applications as an engine. And it could really attach the application in a few days or few seconds, by the way, and use it for political domains, religious domains, and keep going. This is very important. Through this, I could create unified software engineering user. So all what I'm really building is reusable. And it has all the property you might think of, all the properties. Unified word, unified domain dictionaries. I could read for words and domains dictionaries people would use. It's different than glossary. Glossary for an instance of the application, instance of the domain. It doesn't make any sense, to be honest with you. So at the end, forgive me, I do a library for industrial objects or application objects. Those are the concept, which I'm going to use for application. They come and go. They're changeable. Okay? Let's see what's up here. So additional early units, unified words, unified word engineering, unified modeling language, FUML, UML. The existing model language has a lot of problems. So, and actually missing a lot of stuff too, and actually doesn't give you anything to really help you, which is heuristics. Everything we build in UML is actually has to be unified also. So if I build a class diagram, it has to be a unified class diagram. If I put an actor there, for example, a human on hardware, that's it. That means UML cannot build any justice application or many different business application. Why? Or many different biological application. This is application is so all over the place. So limit our application to human or hardware. This does not make any sense. I extended beyond that. So I actually doesn't really add any party. I have a lot of wonder with any parties. So any party would include every element in the society. Say, and this is by law. This is again, that's why this is a new unified UML. And I'm a master of doing this, a master of building architecture for any system. Any system is actually going to be stable and unified. Engine, build the engine from now on. Kind of really going and actually building instance-oriented application, it's going to be crazy. It's crazy already. Unified software engineering management. Unified data visualization engine, because this is part of really software. We have to show animations. We have to show many different way of presenting the data visually as well as textually. Unified business rules, because what I'm building in this system, anybody going to use it, they have to be a business rule there. They have to follow the business rule exactly. And no, yes, you could apply it any way you want to, by the way. You could extend it, you could really scale it down, you could scale it, I could do anything with it. So, additionally, all this is what we're talking about too, by the way. Motivation one. New uniformity in course content and material across many universities and industries. Unfortunately, we don't have that. And this is a dilemma. We educate people and actually think that to teach them and how to apply things based on concepts and I could choose any part. For example, some people actually teach software engineering course as design patterns, where they can go for on others. This is not software engineering. This is only a small, minute things within programming technology. We need to think of this very well, by the way. So limitation of offering. There is no a lot of offering in many ideas and many units within the software. There is no way, there is nobody teach modeling the way I supposed to be, unified. There's nobody actually take anything with unified software architecture on demand. Doesn't make any sense at all. Keep wondering why. Why do I have to build every instance every time? And everybody doing the same thing? Doesn't make any sense. So, not unified in what offering in different universities, by the way, not enough qualified questions, assignment, and team projects. I have tons of team project and exercise. I'm going to make this public for everybody to use. Huge. There are books of them. So quiz is the same way. This is again the scope and level of depth in content and materials are vary from one place to another. And this is a lot of people teach software engineering. They don't know anything about software engineering. That's why they choose the easiest things to talk to students about, especially an undergraduate. And graduate is a dilemma too, by the way. Ask any software engineer if he knows anything about unified non-functional requirement. They don't even know what a non-functional requirement is, by the way. The challenges do not exist within software engineering courses, but courses, content, and techniques and challenges. This is actually also another problem too, by the way. Because this is, again, it exists in every aspect of software engineering. Because software engineering is a very creative course. And as I told you, it has art and science and engineering. It's not science, it's not art alone, it's not engineering alone. Have it really that way, you could actually create wonder with it, by the way. This is, again, very important. Motivation too. The instructor do not usually have practical experience in software engineering. They also be programmers. Yes, I agree. And actually most of the programmers, they're not good. Only will find genius in programming. This is only a few people exists within a company, big company, by the way. So the others usually do programming, and the language itself as a programming language has a lot of dilemma too, by the way. So the lack of expertise in software engineering and proper knowledge of it. The existing software engineering, this is not their problem. The existing software engineering doesn't have any knowledge. This is a big joke, to be honest with you. That's why we talked about how the people define software engineering course and a critical look at software, existing software, as an art or science and engineering. This is, again, lack of existing unified content, materials for teaching the course, unified base, where every student in different university learn in the right school. They don't learn in the right software engineering, by the way. The key knowledge area, software engineering, it change over time and in a fast pace. And all the changes to come to the instructor, they don't read, they don't do research. The instructors in software engineering usually lecture hired from different companies, they don't do research about it. So they never heard about it. It's too late. An appropriate method must be found to teach software engineering. This is, again, in the right depth and level necessary to achieve maturity in it. If you teach software engineering like a math course or maybe like like marketing course, this is not appropriate. Most of the books actually talk about social science stuff. They're not really having anything else by the way. So this is actually going this Rackham 3. This is lack of proper modeling because defects in your mail and poor expertise. Stop developing instance-oriented software development, please. There's how many people building machine learning? The market with the development of machine learning costs billions of dollars. The marketplace for machine learning is huge, amazing, and they all have problems. They all only focus on one algorithms. It doesn't mean we have this before. We have this in search engine, by the way. We're still building search engine. This is crazy. This is actually we have huge number of search engine. Some of them, they don't even do anything. This is really, we have to start working on unification and stability of the things we do. So stop doing instance-oriented applications. This exists everywhere. In very sensitive system, real-time system, time critical systems, security critical system, it's the same thing, which is crazy. Yeah. Lack of knowledge and understanding of innovation and discoveries in software engineering. This is again, for example, for you to learn what I'm doing, this is required practice on a lot of things and actually critical thinking there. This is again very important. The majority of it is a software engineering course focus on programming aspects. Not the majority, I could tell you all of them. I'm just trying to be nice here. By the way, so this is actually the motivations. Properties to achieve. We need to stop reinventing the wheels. This is making us look like we're not engineers. By doing this, we actually going into the same cycle again. Doesn't mean this is no good. Software independence of the environment and hardware. Let me explain that. What's the environment? Software going to be utilized all over the world. So the environment, for example, software built for the culture here as an environment is different than software built for the cultures in Egypt and in China, because this is culture stuff, environment. What this means more, the banks build all the software. Banks here is built on software. The banks in different countries like Egypt bought a lot of software to run their banks. They cannot use it because it's soft forces them to be on this culture right now. No, you have to really make it for them to apply the way they want it. That's why we have to build the engines. Hardware, I need to separate the hardware from the software here. Because hardware now, dependence on hardware is a dilemma. If I build a system for one machine, I cannot use it for other machine. This is not good. They're called portabilities. This is nonsense. This not happen. Not going to happen, by the way. Buy software for Windows, you cannot use it for Macintosh or Mac. No way. What is this? Why? We have to do this. We have the solution in build engines, unified engines, anyhow. So every word in the dictionary is a pattern, is an engine, has 50 or more discoveries, by the way. This is the only way to engineer. This is the only way to engineer engineer software. No, this is correct. We have to build software the way I'm proposing it. This is the only way. It combines all the ways in it, but in a different ways. It's actually, this is having too many different software architecture, aspect-oriented architectures, service-oriented architectures. Keep going. This is a huge thing too, by knowing. So this is only one architecture which would be suitable to us. Now, stabilize the software engineering products. We need to do that. Software as exists had no value. You buy the entire computer with a lot of software on it, a lot more in cost and value than the computer itself. Doesn't have any value at all. You sell the computer, the software means nothing. Unification of domain analysis in any field of knowledge using Fayad knowledge map. This is not just a regular visualization. No, 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 no. This is a very systematic and actually has a guideline. I can do it. This is very amazing. And I'm going to provide example for you to see. And I did provide just a keynote just a few days ago about that. Understanding the unification of functional and executable non-functional requirements. This is very, very important because this is the problem. We don't know it very well. And this represents the problem space. How to come up with animation solution, animated solution, how to build architectural demands. This is again, this is really, sorry, I'm just going very fast here. I'm here, this is still here. This is again, this will go to the rest of the list here, number 2. Goals. Goals here, we have to achieve unifications, innovations, stability, essentiality, critical thinking, what we teach in software, and actually the course of software engineering, lifelong learning, ethical knowledge. Ethical knowledge, yes. By the way, to tell you, in any words or any domain, the 3 categories there, very important. I don't know if I covered this here, let me see. So let me see, this is again, I'm gonna kind of really, no, this, let me tell you about this, just a note here. Every word and every domain has 3 aspects there, this is very important. Morals, ethics, 60%. I guarantee if anybody knows that. Because we build vicious systems. They're nasty. Most of the software application we do. Some shrink wrap software is fine, but again, you come up to software, they blind. They could really kill you. They could really waste your time and money too, by the way. So they have to have morals in it. And believe it or not, if you're not going to believe me, the non-functional requirement we don't know how to execute or define, they contain that morals. Knowledge, which is actually science and art and engineering, 3%. 10% is actually the development. This is actually, it is itself would be easier to develop, by the way. So, proposed course. Software engineering only widely taught in some universities or industry. The proposed project will accelerate and widespread adaptation of the unified software engineering by developing and sustaining a cadre of academic in-house commercial instructors via an instruction orientation, of course, offered online, ongoing online instruction forum, and several face-to-face instruction meetings. So I'm really going to provide all the possibilities in that course. So offering and evaluating the course at collaborating research sites, including both university and business. In the process, the projects will create an adaptation of the course, mostly online environments, and another adaptation for a minority serving university. So it is really both ways. So I could teach this course from America to any country. I could really teach it in any university. I could teach it face to face too. The 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 technology now, you could interact with as many people face to face, and you could actually be with them when they do the homework. You could actually provide feedback to them. You could spend hours with them if you wish. If the course, and actually I used to do that by meeting a student outside the campus. And of course, the administration at San Jose State University stopped me. Used to spend hours. This is unlimited hours. This is, they don't want me to really provide feedback. And actually, this is mentality beyond belief, anyhow. So, let me say, this is actually, you could really have over, yes, you could really, within the class, you could collaborate with companies, with the whole entire class, to teach them how to do things, by the way, and to help them how to do it, and do it for them. Analyzing several collections of in-classes activity, abstract set of themes, patterns that can help instructor quickly create a new activity as needed. Extending instructional support materials, including grading, guideline, pool of hundreds of team projects, exams, questions, and in teaching for teaching the course. This is very important because, again, it's a dilemma. Sorry, I've been going fast here, so let me go back. I think I have to go back a bit. So the course materials include videos, slides, exams, grading, assignments, team project, instructor manuals, many different instructor manuals. Teaching notes are licensed to Creative Commons. Items are designed to help teachers grade students' work well, available no charge, but only to teachers, by the way. So this is actually to later show you. Instructional models, devote to class time, coach activities, interactive discussion, student presentations by assigning student to view studio, produced lectures, video, delivered via internet or coming into the class. At San Jose State University, students report that they work hard in this course than the most other courses, by the way, because this is very challenging. It's very challenging beyond belief, too, by the way. That's what software is all about, by the way. This is software is the brain for any system. The course is more challenging than most of our courses, by the way. That course, and they learn more than the other courses. That's why I got a conflict with a lot of faculties. I'm crazy. They just consider me. My classes usually have hundreds of students, by the way. This is, and I used to have a lot of students every semester, except a few semesters they just fight me anyhow. Student perform in final exam confirms the students' impressions of their learning, by the way. This is, again, very important. Existing software engineering courses are taught by many programmers, no software engineering expertise, and guide them their limited knowledge of software engineering. This is what really the truth, by the way. Now we have to really create a workforce of instructors and experts in software engineering to do that. This is something very important. Software engineering is vital to all fields of knowledge and very important for the United States of America to advance in many innovations to the future fruitful economy. Software economy is so huge. It's actually very large. So if you look at the airplane, especially the one which is fighting fighters, all airplane, the majority of work is software. Anybody can put all this hardware together. And this hardware, by the way, it's actually come from different parts of the states and different companies and stuff like that. Software is the brain for this. Anything we do, by the way. Therefore, funding agency should be open to creating national and international debate with best expert and instructor for software engineering at any time. Need to do this. There is other funding goes in many different areas, but software, all the funding in software engineering, create research, nobody use, has no value, has no impact on the courses of software engineering, has no impact on the development of software engineering. Yes, they could provide funding everywhere, but software is actually at the dilemma of them. It is at the lowest, by the way, which is actually, this is a huge economy by itself. I told you, look at machine learning alone, billions of dollars. Look at everything you imagine, which is a lot of money. Without really unified software, they cannot do anymore. They just kind of really have to reinvent the wheels all the time. Goes on and do this and actually create technology I don't understand. They cannot do it with software exists as now. So when you say, I have a software to make you millions, it has 94% accuracy. 94% accuracy? Why not 100%? Why is 94%? It means this is actually you're lucky if you make this money. They could give you a percentage to really make you, yes, I might have a chance. It's like really a gambling. There is no gambling here. This is a system. We have to build software not to be gambling. You gamble with your money and your time and your resources is really a problem. So this is, again, something which is I have to tell you. So, future work. We have to prepare curriculum, software engineering for undergraduates. We have to prepare curriculum for graduate students. We have to prepare curriculum for high school. High school have to be introduced to software engineering, not programming. Anybody can learn programming, but they be lousy programmer, by the way. Programming is if that's like a natural language. If you learn a natural language very well, you know how to write very well. You know how to be a master writer, by the way. The same for software. Software engineering, you have to learn this from the beginning. Learning programming without software engineering means nothing. You can build the games, and the games you could fail, that's fine. You could really keep trying and have upgrades forever. That's okay. Then unified software standards for everywhere, for every system, for everything we build. We have to do that. Enough is enough. We don't have any, for concept, no way. Don't think about that. Because concept, it doesn't have a standards. Concept come from everywhere. So it has to be done for the domain and the word, not concept. Software guidelines, have to be done together. Exists a standard too in software engineering doesn't mean anything. It's just a bunch of text. Nobody uses. The funny thing, nobody uses. Standard is amazing. You have to do it right. Right. This is again, like the standard hardware is great because you build hardware that according to the standard, And this is very important. That's why hardware companies are very successful. Software, I don't know. They need actually to think about that. Provide unified software engineering supplements. You teach software for health, industry, healthcare. Teach software for wars or maybe news media. Or this is now is crazy. We need to provide supplement for that to show how to extend the engine to as many applications as you wish. And this doesn't take any time. You see? So this is very important. This is again serious needs. We're looking for, this is a conclusion, we're looking for partners, individuals, professionals, practitioners, and academics to participate in this big projects, by the way. And also universities, software organization, training, high schools, please. I would love to have a partner with high schools to really submit proposal in this direction, by the way. Government organization, and we need endorsement letters. I'm calling on everybody concerned about software engineering to start actually communicate with me and send me endorsement letters. Why? Because unfortunately, research agencies discriminate right away. Second, they don't have the brain power to actually to really go for a risk like this. Why? Because this is the same people. They make software. They actually the head of different organization in the software areas. They just business as usual. Business as usual completely. And of course, they have really a lot of problems. I keep wondering, I made the proposal, they accept for millions of dollars, and the outcome is zero. I study all of this. Software engineering examples, Mr. Victor Basili, I respect this guy a lot, by the way, he's my colleagues. He come up with something called Software Factory. He got a lot of money for doing that. The result was nil. Nil. Guys, really wake up. This is not appropriate. All the research and software testing, I'm following it. I read all of the proposal. I need all of them. I used to be a top reviewer there in many different time. And I keep really telling them this is not acceptable. Please, they have to accept something. And they have to discriminate. This is again, the evaluation process there is very funny. I attend several of them. This is again, and this is a form of corruption, but they don't know it. Because again, there's a lot of bias there, stuff like that. So this is a serious needs. I need that. You don't have to like me. But I'm telling you, this is for your own sake, for all of us. If you want to be the master of what we're doing, we need to do that. Thank you very much. I appreciate it. This is actually some of the areas. We're still working on a lot of stuff too. And we have a lot of books related to all ALUs. And we provide now supplements, which is going to be each one of them for thousands of dollars to really apply. You find there, this is the methodology. It's called Concurrent Software Development Methodology, or SSM, Software Stability Models, been published, and I'm going to just provide you with a lot of lecture on this. Unified words, not concept. Concept only for applications. Knowledge map for unified domain analysis. Fayad, unified modeling language. Stable analysis pattern, stable design pattern, stable architecture patterns, and many more. And unified software engineering. Thank you for listening, and I hope you enjoy the talk. Please communicate with me as much as possible. Some reason on my email, Google doing me some nasty stuff. This is a business, by the way, and Google stopped my email since March 3rd, 2000. And actually, I'm going to talk about it in public. I'm going to make an announcement about this. They stopped my emails. They're just actually very, very vicious. Mr. Google saying, this is not good. This is a shame. Please return my email back. Thank you very much and have a good day. Bye.